Guten Tag, Österreich, und bonjour, la France. And I guess also hello, United Kingdom and United States. At time of recording, you are the top 4 countries for the last 7 days on my YouTube channel. So, this is Rocket Design School number 2, and I'm going to go into here and we're going to build a basic orbiter. Now, the reason I'm doing this is twofold. One, I have friends who have just started, and rather than explain to each one of them individually how to build an orbiter, one-man orbiter, mind you, 3-man orbiters are a different beast entirely. But so I'm instructing them. But beyond that, I'm also doing this as I've done a lot of other things on my channel, but I've never really talked about how to build an orbiter. Now, what makes a good orbiter? First thing you're going to need is that. Back in the days of old, we had something called the Mark I pod, and there's actually a little statue. If you do an EVA and walk over here, there's a little statue right here commemorating it. If you're from post, when did they retire that thing? I think .15, I want to say, because .14 was persist. Right. If you're post .15 Kerbal Space Program, you might not know about this. Let's see. So then you're going to need a separator. Now, this is the only thing that's coming back. This parachute is going to slow your descent once you get to the point that you want to deploy it. Now, we need a name for this thing, so we're going to call it the I don't know. Let's just call it the Cat Orbiter 1. Now, what I do to differentiate projects is I get a project name. In this case, it's Cat Orbiter. Don't know what's up with my mouse right there. In this case, it's the Cat Orbiter, and then 1 indicates that this is the first iteration. Click Save. Now, you can either be... what's the nice way to say daring? Foolhardy, that's it. You could be foolhardy and not have an ASAS module on there. Now, there's 2 options, and for a rocket pod, you're going to want this one, the Advanced SAS module. Go ahead and slap that down onto your rocket. That is going to give you the ability to keep pointed at a specific direction, which in orbit, that's very good. Now, due to orbital physics, your position relative to the planet changes, and therefore you're going to be flipping end over end on the nav ball if you're pointed in the direction that you're orbiting. However, if you turn 90 degrees to either any direction on the nav ball, so say that you're on a 90-degree orbit, if you turn to a heading of 180 or 000, your spacecraft would just rotate. However, you would not be able to change your speed in relativity to your orbit. You would actually be able to shift your orbit over. But that's a whole nother ball of wax that I can cover at some other time. Next, you're going to want some way to maneuver while you're in orbit. So go ahead and drop an RCS tank on there. Now, you can... Sorry, I just get used to clicking that one. I need to switch something. Now, you could, in theory, put a small tank on and call that a good orbiter. I try not to do that, simply because I like the option of having more fuel. Now, with an orbiter pod, you can have either of these 2 engines. They both work, and for the most part, I prefer this one. But, as of late, I've been building it with this one, so it's really up to you. I'm going to pick this one for the video, just because I have a feeling that's what a lot of you are going to go for. Now, the next thing you're going to want to make sure is that you have snap to angles on. If it looks like a circle, like that, you don't have it on. If it's a hexagon, you have it on. Then you're going to want to set up your symmetry. I'm going to go 4. You can do 3, you can do whatever you want. And I'm going to put on these, the RCS thruster block. I like them a lot better than the RCS linear port because the linear port is more useful for shuttles and things that are able to, I don't know, change direction more easily. They have more control surfaces, and you can just pop these all over the place. This is very similar to the Apollo mission style. Now what I'm going to do is I'm going to put some there and some there. Now what that's going to do is allow the spacecraft to turn easier. Now the thing is, you're not going to want to use that until you get into orbit. Now, you're going to roll this up, do that, put on a stack decoupler, and with a pod this small, you don't need to secure it to the lifter itself. For my 3-man orbiters, that's why I say they're a different beast entirely. They're heavier, they like to wobble a bit more, they're a lot bigger. You have other things at play. Next, you're going to need to design a lifter that can get you most of the way into orbit. And when I say most of the way, I mean you're going to want your orbit periapsis to be around 10,000 meters. So, what we're going to do is we're going to go ahead and build an ascent stage. Now you have 2 options here. You can either build them with this, the fuel tank, which with a rocket this small you could do that. It's easier to manage and less unwieldy. But if you're looking to save space, you can use the Rockomax X200-32 fuel tank. So, what are we going to do? Well, it's up to you. I'm going to use this just because it's easier to work with, and I have a feeling most of the people who are watching this are going to use these too. So the standard lifter engine can lift its own weight. So I'm going to go ahead and put this engine on. You'll see why once we launch. And mind you, I honestly don't know if this will get into orbit. Whoa, okay, that was goofy. Okay. Now what I'm going to show you is a way to conserve fuel as you're going up. We're going to put on a radial decoupler, and we have our symmetry set at 4. So I'm going to drop this down to here. I'm going to put these on. Now, these are the outer boosters. Now you can have solid fuel boosters, but I honestly have always preferred liquid fuel for this sort of thing. Now, you have an option. If you want to role play and reuse these boosters, you can put parachutes on the top of them, and you would want to use this parachute. So, I'm just going to go ahead and put a nose cone on. You'd think that that wouldn't make much of a difference, and I honestly haven't seen it, but you know, it looks better. Alright, there we go. You now have your boosters. So, what we're going to do is we're going to take this fuel line, and we're going to put it on the top of this tank and run it, come on now, there we go, and run it to that tank. Now the reason that we're doing that is all the fuel is draining into this central stack, which means each of these only, there's math involved, but not all of the fuel goes down to this this engine. I want to say something like 80% of the fuel in each of these stacks is going to be used at that engine, but 20% of each of those is going to be used to fuel this. Now, it would be 25, but we're using different engines with different thrust and max velocities and stuff like that. Now, the other thing you're going to need to do, otherwise this will wobble all over the place, because all you have is a securing point down here. I'm going to go ahead and secure the bottom like that. So you see we have a nice secure fitting right there. So it's not going to really want to wobble around at the bottom. And at the top, what we're going to do is secure it right there onto the main stack. Now, with the orbiter itself being so small, you're not going to have to secure it. For a 3-man orbiter, you might want to secure some of it. That's really up to you as much as you design your orbiters. But this is generally a pretty good style of lifter stage. Like I said, I'm just flying by the seat of my pants here. I'm not entirely sure that this will get into orbit. I've got a good feeling about it, but, you know, science, fairies, those things that mess with your mission. Now, this would be pretty solid. Your gimbling engine would not be touching the ground, and these would be touching the ground. You can launch like this if you want. However, alternatively, you could also put these on here like that below your struts, and then lower it to the ground, and you wouldn't have anything touching the ground. So we're going to do that, and you see I put it underneath my strut, and then we're going to bring the rocket itself down. If you don't put these, I'm not sure what they're called. They're called double T18-A launch stability enhancer. Okay, basically, they hold on to the ship right before it takes off. Now, these cause problems, and they also solve problems. They can bump into your ship and blow it up, or they can, you know, prevent your ship from blowing up by wobbling itself off the pad, and yes, I have had that problem before. The next thing you're going to want to do is you're going to want to mess with all this staging, because right now this is really inefficient. In order to start the orbiter stage from the lifter stage, you're going to have to tap twice in order to do that. The only time that you want to tap twice is between stages 0 and stages 1. Stage 0 is deploying the parachute. Stage 1 is deploying that decoupler right there. However, this decoupler and this engine, you see them lighting up on my ship, you want to go at the same time. So rather than moving everything down, we're just going to move that decoupler up into 2. Now what that's telling the computer on the ship to do is, as soon as it decouples, you're going to go ahead and start the engine, which that is a really good way to keep your mission going very smoothly while not losing altitude if you haven't reached an apoapsis yet. I'm sorry, not altitude, velocity. Okay. Next, we're going to want to move this up into... Yes, we're going to want to move that up into this stage. But we're not going to have this engine light off in this stage. The reason is because we would be pumping fuel into a full fuel tank. So what we're going to do is we're going to move this engine down to 4. Now we have technically a 4-stage orbiter. But as you see, we've compressed it down from a 6-stage orbiter. And this compression makes your missions a lot smoother. The only risk is, if you build a really big and really complex ship, it's very, very easy to lose track of this. So that is how you build your basic orbiter. Now, you don't have to follow this design exactly, you can mess with things, but what you're going to find is a lot of the orbiters actually look like this. Your first orbiter itself that's efficient, that you like, that you use, is going to look like this. And this is very good for rendezvous, it's good for getting the basics of orbital physics, it's good for figuring out circular orbits, transfer orbits, parking orbits. Basically anything that you can do with orbits, this is going... Pointing at the screen like you can see where my fingers are. This is going to be a very efficient design. Now, if you don't have enough juice, what you can do, without affecting the delta V too much, is strap some solid rocket boosters to the side without a decoupler. And the reason is the dry mass of the solid rocket boosters, even the big ones, isn't that big. The dry mass is 0.075, and that is negligible in delta V, which is the ship's thrust ability. Now, the other thing that you're going to want to do to make your launches a little bit easier and your life a little bit easier, as you see, the center of mass is right here. And you don't have to do this, because of the gimbling engine in the middle can direct the ship very easily. But if you want to make maneuvering a lot easier, take an R8 AV- the winglet thing, and you put it here, and you see that little blue ball inside the mass ball. If you put that there, let's save the Cat Orbiter 1. If you put that there, that means the center of mass and the center of rotation for your winglets is the exact same place. Now, it's going to change once you get your boosters spent. That's going to fall away. You're not going to have your center of lift, I think it's called. Yes, you're not going to have your center of lift. However, you're not going to need it because you have this vectoring engine down here. And what you can do is you can use that to roll, and you do that on minimal power. So why don't we take this out to the launch pad, and we're going to go ahead and see how it flies. And launch pad. So yeah, this is this is an experiment. Oh, don't you do that to me. There we go. Let's see who we got. We got way too complicated name, Kerman Shelnard. Alright. Now, getting back to the tutorial-y part of this video, as you see, we have this nice clearance between the tower and the rocket itself. Now that circle also corresponds with the circle in the KSCVAB. Yes, I knew exactly what I was talking about while I was saying it. Kidoki. Anyways, what we're going to do is we're going to hit caps lock because I don't want to be tumbling end over end uncontrollably. We're also going to hit T in order to turn on the SAS, which is this unit right here. Now that entire computer can power this entire ship. Then we're going to hit shift until we get all the way to 100% throttle. So there's no countdown, so I could either, count down myself or just go like that. Hello. Oops. Alright, here's exactly what just happened. These are counted as stage 5, but I need them to be counted as stage 4, so as soon as I hit this button, it'll go. Oh, goodness. And that is exactly why we have the vehicle assembly building button right there. Holy cow. I forgot to check. You need to put these in the bottom stage, otherwise it's not going to go. And I really don't need a stage for that, so... Yeah, the design is fine. You got to check your programming, which when you start messing with it to make it more streamlined is when you can run into troubles. But attempt number 2 to launch. So basically everything I just said except with better programming. Caps lock T shift. Okay, there we go. Caps lock T shift. Not the order I hit those buttons. Okay. 5, 4, 3, 2, 1. Launch. As you see, we are going straight up and down, which that is a very, very, very good thing. Now, what we're going to do is we're going to hope that this rocket will pick up enough speed by the time that we leave the thick part of the atmosphere, which is around 15,000 meters, that we're going to be able to get into orbit. If not, I'm going to have to fiddle with this, but at the same time, the principles of this design are still good. I remember back in point 1.2, that was a ridiculous game. You had these crazy complex things to get into orbit, or at least I did. I mean, I've been playing this for over a year, so I guess I should kind of know what I'm talking about. Alright, so you hold F to turn off the SAS. So what you're going to do is you're going to roll up. Now, as you see, we're going overboard just a lot of it. Holy crap, dude. Okay, what the bloody blue blazes is causing that? Wow. Well, we're definitely shooting sideways. Jeez Louise. I love your rocket design. The only problem is it doesn't go where it's supposed to. Yeah, I know. Alright. Now, why would it be doing that? Well, that was no bueno. Alright, we're going to try this again. I feel like I could pull a good flight out of this, and I'm just missing something very obvious. So we're just going to redo everything I just did. When the game lets me, I keep forgetting it's got a little hiccup. Alright, there we go. 3, 2, 1, launch. Alright, instead of doing a gravity roll at 5,000 meters, which I probably should have explained what that was, we're just going to let these boosters burn out, because I have a feeling they're what's causing my problem, because they're throwing the center of mass off, and therefore the center of lift is not exactly over the center of mass. So, we just going to sit back. Now, I mentioned a gravity roll. Under normal circumstances, I would roll the orbiter about to 60 degrees above the horizon along a 90-degree heading in order to start building up some eastward momentum, while still mostly putting most of my energy into going up and down, vertically. So what we're going to do is we're going to wait for these to burn out, because I doubt it's going to take too terribly long, because they're not only fueling those powerful non-vectoring engines, they're also helping to fuel that center stack. Which, if you take a look here, you're going to see some fluctuating... Oh, really? Nice. Occasionally what you'll see there in the older versions, I haven't really checked it out that much in the newer versions, is a fluctuating number representing the amount of fuel in there. And as you see, we're picking up a lot of speed relatively quickly, and we're getting a G buildup actually a little bit because of how fast this rocket is moving. So what we're going to do... Okay, we're going to hit M. Because if I start getting up over 60,000, we have an issue. Oh my goodness. That's a brilliant idea. Let's test an orbiter. The world is that. Oh. Oh crap. Okay, that was actually from my design school 1. Now as you see, we have a little bit of fuel left, but we need to get rid of it. So go ahead and do that to detach those. Throttle up a tiny bit, then we're going to start rolling. Now, this ship isn't so unwieldy that we can't just do this like this. However, if your ship is unwieldy and big, you're going to need to have a tiny, itty-bitty little piece of power going on in order to balance out everything else, because the vectoring engine is very good at directing where your ship goes. Now, I really hope I don't run into the IP lander, because that would be terrible. Okie dokie. Or the 3MIP lander. That's exactly what it sounds like. Now what we're going to do is we're going to spread this out a lot. And hopefully no science fairies descend and decide that we need to die. So the speed to get into orbit is quite intense. Depending on the altitude, it's anywhere up to 2,200 meters per second. What I'm going to do is I'm going to let this bump up to 100,000 meters, and when I have that happening, I'm going to be able to... wait until I get to the apoapsis, which is the highest point of the flight. I probably should actually have this as my Rocket Design School 01, but hindsight is 2020. It's also probably going to be one of my more talky videos, throwing back to the days of old, where my videos were such things as Drunk Ass Moonshot Part 1 and Part 2. But I don't talk about those much. So, as you see, I should probably explain my flight pattern. I am at 10 degrees above the horizon along the direction that I would like to travel. The heading, is very, very important. It's easier to burn to 90 degrees because you're incorporating the Kerbin's rotation into it. However, it's also more fuel efficient. You could burn to 270, but you're going to waste a little bit of fuel countering out Kerbin's rotation. Now, I don't like intersecting orbits. I do not like them, Sam. I do not like intersecting orbits with green eggs and ham. What the heck was that? Did anybody else see that? There was like a flash right there? That was weird. Anyways, as you see, I have, I have 51.2 liters in that tank, which means I've got about a quarter... No, I've got like an eighth of a tank left. Now what we're going to do is we're going to sit here until we get to 100,000 meters, roughly. And the best time to burn is now, at about 20 seconds before the apoapsis. Now as you see, we've been able to conserve a lot of our speed. We're still moving at about 1,500 meters per second. Excuse me. 1,500 meters per second. Now you're just going to bump it down so that you're on 90. And even if you pass 100,000 meters, you're still going to be moving up a little bit. So as you see, the the time to returning to the apoapsis is 21 minutes because it's assuming that you're just going to orbit through the planet instead of land. Now what we're going to do is we're going to slow it down a little bit, and as you see, the trajectory is coming around the planet on this side, and it's also going to be coming around the planet on that side. So what we're going to do is the apoapsis, you're going to want to cut it off while it's still in the atmosphere. Did that not autosave? Oh, that sucker's going to crash if I don't do anything. Wow, that's bad. I'm going to go ahead and get this into orbit, end this video, and then ground all my flights. So, we're done with this stage because we don't want this just floating in orbit as space debris. Right now it's going to burn up in the atmosphere when it returns down to 15,000 meters. So what we're going to do is we're going to hit space to stage. Then we're just going to throttle up, and we don't have to hit space again, and we're going to pick up the amount of speed that is required to make a circular orbit, or very close to it. So what we're going to do is we're going to swing this out to my preferred apoapsis. And my preferred apoapsis is 300,000 meters. And I'm going to either under or overshoot it a little bit. That always happens. So I'm going to explain how you correct for that without having to flip your ship every single way. So we're going to go ahead and stop at that, 98. Now as you see, we still have a lot of fuel left in this pod, and I like it because that means we have more orbital options. Now, as you see, I've undershot it by about 2,000 meters. Some kind of argument going on outside my outside my apartment. So what we're going to do is we're going to turn on RCS by hitting R. Now the controls for this are WASD to rotate your ship and Q and E to roll it. Now H and N are forward and reverse. So as you see, I'm able to manipulate it by hitting H and N. IJKL is what you use to laterally move your ship. Now when you get out here, you're going to burn until you make a nice circular orbit, and I think I actually have a tutorial on that. That's still good from the older game. Anyways, this has been that one guy with Rocket Design School 02. Thanks for watching. Have a nice day.